Okay everyone, Dave here, back again. I thought I'd do a quick video on the DropArt Bootloader. I generally do a bootloader explanation for any of the projects that I put together, because in the past the bootloader has caused a bit of confusion and I can kind of understand why. Okay, so let's just talk about what a bootloader is. Now, as we've or as I've pointed out or explained in previous videos, this project, the DropArt project, is based around a PIC microprocessor. In this particular case, a microchip PIC 18F2550 microcontroller. Now that microcontroller is run in software, or it's firmware. I prefer to call it firmware, which is basically a program running on the PIC. Now that program is in non-volatile memory, it's in flash memory, so that means that when the PIC is powered down and powered up, the program or the firmware is retained, and you don't need to reprogram it every time. However, you do need to get the firmware on there in the first place. Now there's kind of like two ways of doing that. During development, the usual way to do it is to use the PIC programming header here, and I use a sort of credit card size programmer called a PIC Kit 3. That's got USB one side and the PIC pin header the other. You plug it into the PC, you use the design environment, write your software, and then flash the PIC over the programming header, because it's really fast and it gives you other debug features that might be useful. However, if somebody else, say for example, read this article and decided they wanted to build this project, I can flash them a PIC, no problem, with the latest firmware and send it to them. But the chances are that they might require a modification or a new feature, or maybe there's a bug, or something could happen, in which case the firmware needs to be updated, reflashed. So in that circumstance, they'd have to send the PIC physically back to me. I would have to reprogram it and then send the PIC physically back to them. It's all a bit inconvenient and time consuming. So the purpose of a bootloader is to allow somebody without a specialist programmer to reflash the PIC, in this case over the USB. So the bootloader is a small program that runs, in this particular case, in the first page of the PIC's flash memory, so it's permanently retained even after power up, or power down rather. Now what happens is when you power the board up or reset the PIC, control is actually passed to the bootloader. And the bootloader examines a set of or a particular circumstance. That in this particular case, that circumstance is having this button pressed, this rotary button pressed. If that button is not pressed during power up or reset, the bootloader just passes control directly to the application, and as we see here, the application comes up. So I can demonstrate that if I reset there. So the application came up because the bootloader didn't run. The connection LED is on because we've not connected the DropArt PC application. Okay, so if the bootloader does see this button pressed, then the bootloader executes and doesn't pass control to the application. So the bootloader executes, and then what it does is the bootloader establishes a connection with the PC DropArt bootloader, which you can see in the top right hand corner of the screen. So it establishes a connection with the PC, and then you can then, via the PC application, choose a new hex file. The hex file is the format that the firmware comes in, basically. It's the output from the design environment on the PC. So you pick your hex file, which I would have generated. I would have made the modifications and created a new hex file, which I've sent to you. You pick the hex file, and then the new firmware is then reflashed over the USB connection. So you basically, the upshot is you can reprogram the firmware without needing a specialist programmer. Okay, so let's see that in action. So you can see that the DropArt PC application is currently all grayed out and not doing anything. So let's invoke the bootloader. So if I press the center button and then reset, I could power down, but I'll reset. Now you'll notice that the USB LED is now rapid flashing. That means that the PIC has recognized that bootloader mode was required and is entered bootloader mode and is flashing this LED to let you know. Also notice that the DropArt bootloader PC application is sort of come to life, and we've now got a message saying DropArt PIC attached. All good. So then basically it's now this simple. So on the PC application, we open the hex file. So there, I've just happened to be in the right directory. So there's the DropArt hex file. It's obviously going to be, in this particular case, the same firmware that was already running, but you know, it doesn't have to be. It this could be modified firmware. So I'll select that, open it, and then just hit Program Verify. So it erased and then it waited, and erase was complete. Program started, program complete. Verify, then it performs verification, so then it reads all the firmware back from the PIC and then checks it against what it was programmed, the image on the PC. So it says erase, program, verify, complete successfully. That's it. Now I can reset. So if I hit the reset here on the PC, done. So you'll now notice, because obviously the button, the board reset, because I reset it from the PC, or I could have reset it from here. I mean, if I reset it from here, it doesn't make any difference, resets, but it's now obviously running the DropArt application. And that would be potentially a new application if we were doing this in the field. So that's it, basically. That's the bootloader operation. So if you want to build one of these, then I can send you firmware updates, and you don't need a programmer. In fact, you don't even need to fit this header, because the PIC will come with the bootloader installed. So this would effectively be redundant to anybody that built this, other than me. Okay, anyway, right, thanks for watching. Cheers.